Hello students, today we will be solving another paper from Pure Maths paper 1 from May-Jun 2016, variant 1. Question number 1, find the term independent of x in the expansion of x minus 3 over 2x to the power 6. So independent of x means without x, and without x we can consider it as x to the power 0. That is what they are talking about. So for that, first we need to write 6cr and then x to the power 6 minus r minus 3 over 2x to the power r. Then we need to isolate the x terms only. So that will be x to the power 6 minus r, and if I just isolate the x term from this, I get x to the power minus r, and that should be equal to x to the power 0. So we need to figure out what will be the value of r for which I will be getting the independent term of x. So since there is a multiplication, that means we need to add these two powers. So it will be 6 minus r, and if I simplify this, I get x to the power 6 minus 2r equals to x to the power 0. With the help of equality rule, I get 6 minus 2r is equals to 0. So 2r is equals to 6, therefore r is equals to 3. So now we know what will be the value of r for which we will be getting the term which is independent of x. So it will be 6c3 x to the power 6 minus 3 over 2x to the power 3. That gives us 20 times x cube times negative 27 over 8x cube. Simplifying this further, we get minus 135 over 2, and you can see that x cube and x cube, they both cancel out. So simplifying this further, we get minus 67.5. So this is the term which is independent of x. In the next question, solve the equation 3 sine squared theta equals to 4 cos theta minus 1 for theta lies between 0 and 360. So we can say 3 sine squared theta minus 4 cos theta plus 1 equals to 0. And what I'm trying to do here is bring everything to cos theta. So sine squared theta can be written as 1 minus cos squared theta. And then if I multiply, I get 3 minus 3 cos squared theta minus 4 cos theta plus 1 equals to 0. Then if I bring the quadratic factor in the first place, it becomes minus 3 cos squared theta minus 4 cos theta plus 4 equals to 0. If I multiply negative 1 on both sides, it becomes 3 cos squared theta plus 4 cos theta minus 4 equals to 0. Now with the help of substitution, I can consider, let's say, x is equals to cos theta. That makes it simple to solve. So 3x squared plus 4x minus 4 is equals to 0. And then I'm doing middle term. So this becomes 3x squared plus 6x minus 2x minus 4 is equals to 0. Now if I take 3x common, this becomes x plus 2, and if I take minus 2 common, I get again x plus 2 equals to 0. So the factors are 3x minus 2 and x plus 2 equals to 0. Therefore, x must be 2 over 3 and x must be negative 2, which is the same as cos theta is equals to 2 by 3 and cos theta is negative 2. Now, if you know that the default cos theta, the graph of default cos theta, the maximum and minimum lies between positive 1 and negative 1. That means with negative 2, if cos theta is negative 2, we will be not getting any solutions. So we can only continue with this value. So cos theta is equals to 2 over 3, which is a proper fraction. And now let's find the basic angle. So alpha is equals to cos inverse of 2 over 3, and we get alpha is 48.19. And we know that positive cos lies in the first and fourth quadrant. And also the limit that we are provided with is theta lies between 0 and 360. That means we can take both of these quadrants. So the first angle, the basic angle, will be the actual angle, which is 48.2. and the other one will be 360 minus 48.19, which is 311.8. Question number 3. The diagram shows part of the curve x equals to 12 over y square minus 2. The shaded region is bounded by the curve, the y-axis, and the lines y equals to 1 and y equals to 2. Showing all necessary working, find the volume in terms of pi when this shaded region is rotated through 360 degree about the y-axis. So we need to find the volume, and it is being rotated 360 degree about the y-axis. So let's first find what will be x square. So if x is 12 over y square minus 2, x square will be 12 over y square minus 2 whole square. So we will be using the formula a minus b whole square. That gives us 144 over y to the power 4 minus 48 over y square plus 4. Simplifying this, or we can rewrite it as 144 y to the power negative 4 minus 48 y to the power negative 2 plus 4. So we know that for volume, and if the diagram is rotated 360 degree about the y-axis, we need to consider pi integration x squared dy, and the limits are 2 and 1. If you can look into the diagram, these are the limits. This graph is being rotated 360 degree about the y-axis. So pi integration, the limits, upper limit is 2 and 1, and we need to integrate this. So this will be minus 4 plus 1, which is minus 3, and in the denominator we have minus 3, and minus 2 plus 1 is minus 1, and we have minus 1 in the denominator, and plus 4 will be 4y. So the limits again are 2 and 1. Now if we simplify this, this becomes 48, and double negative makes this positive. So the volume, we just simply now have to substitute the value 2 and 1 into this equation. So simplifying this, we get 26 minus simplifying this, we get 4. So it will be 22 pi. And you need to remember that in the question it stated that find the volume in terms of pi. So we have to leave our answer in terms of pi. I highly recommend that you read the question properly. After you are done with answering, check the question one more time to see whether they have asked to leave it in exact form in terms of pi or something similar to that. Question number 4. A curve is such that dy over dx is equals to 2 minus 8 times 3x plus 4 to the power minus half. A point P moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.3 units per second. So this means dx by dt is equals to 0.3 because x coordinate is increasing at a constant rate. This should give you the hint of dx by dt. We need to find the rate of change of y. That means we need to find dy by dt as p crosses the y-axis. Okay, so for p, we know since it will be crossing the y-axis, x must be 0. So they have provided the value of x indirectly. They are stating that p crosses the y-axis, and we know that at y-axis x is 0. And dy by dx is this equation, and dx by dt is 0.3. In order to find dy by dt, we need to use the chain rule. So the chain rule would be dy by dx times dx by dt. So when x is equals to 0, dy by dt must be 2 minus 8 over 0 plus 4. So 3 times 0 is 0 plus 4 to the power positive half, because I have brought this in the denominator, times dx by dt is 0.3. If I simplify this, I get negative 2 times 0.3 equals negative 0.6. And that will be the answer for part 1. In the next part of the question, it says the curve intersects the y-axis where y is equals to 4 over 3. Find the equation of the curve. So when the curve intersects the y-axis, again x is 0. So the coordinate is basically 0 and 4/3. So to find the equation of the curve, what we need to do, this was dy by dx. So if we integrate this with respect to x, we will be getting the equation of the curve. So integrating 2, we get 2x. And for this, power is the operator. So this is the box. So we need to differentiate the box, which gives us 3. And in order to balance this, I have 1/3 over here. So then the integral sign and the differentiation of the box and dx will disappear. And then we are left with the power to integrate. So minus half plus 1 is positive half, and we need to bring the half in the denominator as well. So y is equals to 2x minus 8/3 times 3x plus 4 to the power half divided by half plus c. Now to find this constant c, we will be taking the help of the information given in the question, which is the coordinate is 0 and 4, 3. So at 0, 4, 3, this is satisfying the equation of the curve. So we simply substitute this coordinate into this equation, and we get 4/3 is equals to 2 times 0 minus 16/3 times 0 plus 4 to the power half plus c. Simplifying this, we get 4/3 is equals to minus 32/3 plus c. So c must be 12. So the equation of the curve must be y is equals to 2x minus 16/3 times 3x plus 4 to the power half plus 12. Question number 5. A farmer divides a rectangular piece of land into 8 equal-sized rectangular sheep pens as shown in the diagram. Each sheep pen measures x meter by y meter and is fully enclosed by metal fencing. The farmer uses 480 meter of fencing. Show that the total area of land used for the sheep pens a meter square is given by this equation. So for this, let's draw the diagram again. That will give you a better perspective. So this is, the width is x and the height is y. So all these are x, y's. So now, since 480 meter of fencing is used by the farmer, so that means there are 12x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there are 10y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 12x plus 10y is equal to 480. If I divide both sides by 2, I get 6x plus 5y equals to 240. So y is equals to 240 minus 6x by 5. Simplifying this further, we get y is equals to 48 minus 1.2x. Now, for the area, we know that the area will be x times y for one sheep pen. And there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So x times y times 8 must be the area. And we know that y is 48 minus 1.2x. So we can simply substitute this into this equation. And if we simplify this further, we get a is equals to 384x minus 9.6x square, which they have asked us to show. In the next part of the question, it says given that x and y can vary, find the dimensions of each sheep pen for which the value of a is a maximum. There is no need to verify that the value of a is a maximum. So a is this, and whenever you are asked to find the value of a for which it's a maximum or minimum, we need to do differentiation. Also, at maximum or minimum, dA by dx will be equal to 0. So let's first differentiate this. So 384x will become 384, and this will become 2 times 9.6 is 19.2, and x to the power 2 minus 1 is 1. So 384 minus 19.2x is equals to 0. Therefore, 19.2x is 384. So x must be 20. So when x is 20, we can substitute this value into the equation of y, which we got earlier, which was 48 minus 1.2x. So y is equals to 48 minus 1.2 times 20, that gives us 24. So the required dimension is 20 by 24, where x is equals to 20 and y is 24. Question number 6. Find the values of the constant m for which the line y equals to mx is a tangent to the curve y equals to 2x square minus 4x plus 8. So this question has got to do with the discriminant. So we need to find the values of m for which this line and this curve, this line is a tangent to this curve. That means it will be meeting at one point. That means the discriminant must be equal to 0. So these are the two equations and we need to equate them since they are meeting. So y equals to y, that means 2x square minus 4x plus 8 equals to mx. And we bring everything to the left hand side. So 2x square minus 4x minus mx plus 8 equals to 0. So 2x square plus minus 4 minus m, I'm figuring out the coefficients of x only. So which gives me minus 4 and minus m plus 8 equals to 0. So if I compare this with the quadratic equation, which is ax squared plus bx plus c, that means a is 2, b is negative 4, negative m, and c is 8. So for the tangent, as I said earlier, that means since they will be meeting at one point, the curve and the line is meeting at one point, hence it is a tangent. Therefore, the discriminant must be equal to 0. So b square minus 4ac, that is minus 4 minus m whole square minus 4 times 2 times 8 is equals to 0. So if I expand this with the rule of a minus b whole square, I get 16 plus 8m plus m square, and this is minus 64. Simplifying this, we get m square plus 8m minus 48 equals to 0. Or we can say m square plus 12m minus 4m minus 48 equals to 0. So taking m common, we get m plus 12, and if I take negative 4, I get again m plus 12. So the factors are m minus 4 and m plus 12 equals to 0. That means m is equals to 4 and m is equals to negative 12. So these are the two values for which the line will be a tangent to the curve. In the next part of the question, the function f is defined for x is an element of real values. The function is x squared plus ax plus b, where a and b are constants. The solutions of the equation fx is equals to 0 are x is 1 and x is 9. We need to find the values of a and b. So you can see that there are two unknowns and there are two informations which have been provided. That means it will eventually lead to simultaneous equation. So simply we need to use these two values. So when x is 1, it will be 0, and when x is 9, it will also be 0. So we simply substitute this into this equation. So 1 squared plus a times 1 plus b equals to 0. That gives us a is equals to negative 1, negative b. Let's consider that to be equation 1. And when x is 9, it will be 9 squared plus a times 9 plus b equals to 0. That gives us 81 plus 9a plus b equals to 0. So 9a plus b equals to negative 81. Let's call this equation 2. Now let's substitute this equation into this one. So we get 9, instead of a we can write minus 1 minus b plus b equals to negative 81. So minus 9 minus 9b plus b equals to minus 81. So minus 8b is negative 72. So b is equals to positive 9. Now we can substitute this into this equation to find out the value of a. So a is equals to minus 1 minus 9, which is minus 10. In the next part of the question, the coordinates of the vertex of the curve y equals to fx, that's what we need to find. So vertex means the turning point or stationary point. So this was the equation. Let's consider y is equals to x squared plus ax plus b. And we know the value of a and b by now. So a is negative 10 and b is 9. So that means x squared minus 10x plus 9. Now let's do completing square, because with the help of completing square, we can find the turning point. So x minus 5 whole square minus 5 whole square. So first we take x, then this negative, and we divide 10 by 2. That gives us 5. We make it whole square, then take away this 5 whole square plus 9. So x minus 5 whole square minus 25 plus 9. Simplifying this, we get x minus 5 whole square minus 16. So the turning point, which is the vertex, is 5 and negative 16. So that is the same as the vertex. Question number 7. In the diagram, AOB is quarter circle with center O. So AOB is quarter of a circle with center O. The point C lies on the arc AB. The point C lies on the arc AB. And the point D lies on OB. The line CD is parallel to AO. And angle AOC is equal to theta radians. We need to express the perimeter of the shaded region in terms of r, theta, and pi. So the arc length, let's first find the arc length of BC. So the formula for the arc length will be r theta, where the radius is also r over here, and theta is, this is 90 degree, which means pi by 2. And if this is theta, that means this angle must be pi by 2 minus theta. So that is the arc length for BC. Then in triangle OCD, this triangle OCD, CD is equals to r sine pi by 2 minus theta. So r is the hypotenuse, and I'm considering this angle again. So since this is the hypotenuse and we need to find the opposite CD, so CD must be hypotenuse times sine of this angle. And for OD, again, we consider the hypotenuse times cos of this angle because it is adjacent to the angle. So it will be cos pi by 2 minus theta. So simplifying this, we can say that r sine pi by 2 minus theta. So sine 90 minus theta is cos theta. This is trigonometric rule. Similarly, cos 90 minus theta is sine theta. So dB, which is this, dB must be r minus r sine theta. dB must be OB minus OD. So we got OD, which is r sine theta. This is r sine theta, and the whole thing is r. Because if this is radius, this is also radius, OB is also radius. So just the part BD will be r minus r sine theta. So the required perimeter should be, this is the arc length, which is r times pi by 2 minus theta, plus r cos theta plus r minus r sine theta. In the next part of the question, for the case where r is equals to 5 and theta is equals to 0.6, find the area of the shaded region. So area of the sector AOC. So what I'm trying to do here is, in order to find the area of the shaded region, my plan is to find these two areas. This is also a sector AOC and this triangle ODC, and then I will add these two and take it away from the area of the complete sector, which is AOB. So area of the sector AOC is half r square theta. So half, the radius is given now 5 and theta is 0.6, that gives us 7.5. In triangle ODC, we found that CD is equals to r cos theta. So CD must be r is 5 and theta is 0.6. So 5 times cos 0.6, which gives us 4.127. And OD is r sine theta. So that means 5 times sine 0.6. That gives us 2.823. So we have the height of the triangle and the base of the triangle if you consider the triangle ODC. So the area of the triangle ODC must be half times base times height, which is half times 2.823 times 4.127, that gives us 5.825. So now we just have to find the area of the whole sector. So area of sector OAB must be half r square theta, and now the angle is this whole thing, 90 degree. In radians it's pi by 2, so half times 5 square times pi by 2, that gives us 19.635. So the required area must be the area of the complete sector minus the area of the small sector and the triangle, which gives us 6.31. Question number 8. A curve has equation y is equals to 3x minus 4 over x and passes through the points A 1 minus 1 and B 4 11. At each of the points C and D on the curve, the tangent is parallel to AB. Find the equation of the perpendicular bisector of CD. So let's first find the equation of line AB, because the tangent at the point CD on the curve is parallel to AB. So with the help of these 2 points, we can use the formula y minus y1 over y2 minus y1 equals to x minus x1 over x2 minus x1 to find the equation of the line. Since we are provided with these 2 coordinates, we can straight away use this formula. So 3y plus 3 is equals to 12x minus 12. So 3y is equals to 12x minus 15. Therefore, y is equals to 4x minus 5. So this is telling us, this equation of the line, that the gradient of this line is 4. That means the gradient of the tangent, which is parallel to this, must also be 4 because it's parallel. That's why I'm stating that dy by dx is equals to 4. So the equation that we have, y is equals to 3x minus 4 over x, this equation, which is the equation of the curve, we need to differentiate it. So y is equals to 3x minus 4x to the power minus 1. So the dy by dx will be 3 plus minus 1 times minus 4 is positive 4, and x to the power minus 1 is negative 2. So dy by dx is 3 plus 4 over x squared. So this differentiation must be also equal to 4. We just need to figure out what will be the value of x for which the gradient comes to 4. So 3x squared plus 4 is equals to 4x squared. So what I did here, I did the LCM and I multiplied x squared with 4. That gives us 3x squared plus 4 is equals to 4x squared. So minus x squared is equals to negative 4. So x squared is equals to 4. I'm just multiplying both sides by negative 1. So x will be plus minus 2. So when x is 2, if I substitute this into the equation of the curve y, because this must be satisfying the curve as well. So y is equals to 3 times 2 minus 4 over 2, which gives us 4. So the point C must be 2, 4. And when x is negative 2, I'm again substituting this value into the equation of the curve, and I'm getting y equals to 3 times negative 2 minus 4 over negative 2, that gives us negative 4. That means D must be negative 2 and negative 4. Now we have the points. So let's first find the gradient of CD. The gradient of CD will be y2 minus y1 over x2 minus x1. And since we have the points for C and D, we can say minus 4 over minus 2 minus 2. That gives us positive 2. And since we need to find the equation of the perpendicular bisector of CD, that means it will be going through the midpoint of CD. We need to find the midpoint as well. So the formula will be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. That gives us 2 minus 2 by 2 and 4 minus 4 by 2, which is 0, 0. And since the gradient that we got for the line CD is 2, that means the gradient of the perpendicular bisector will be the negative reciprocal of this. So it will be minus half. So now we have the point through which it will pass, the perpendicular bisector, and we also have the gradient for the perpendicular bisector. So we can use the formula y minus y1 equals to mx minus x1. So it will be y minus 0 equals to minus half times x minus 0. So that gives us y is equals to negative half x. And this is the equation of the perpendicular bisector for CD. So since it's an arithmetic progression, we can say that second term minus first term is equal to third term minus second term. So that gives us 3 cos x minus 2 sin x equals to sin x plus 2 cos x minus 3 cos x. So 3 cos x minus 2 sin x equals to sin x minus cos x. Minus 2 sin x minus sin x. So I'm bringing all the sin x to the left hand side and I'm taking away all the cos x to the right hand side. So that gives us minus 3 sin x equals to minus 4 cos x. If I multiply both sides with negative 1, I get 3 sin x equals to 4 cos x. Now, if I cross multiply, I get sin x over cos x equals to 4 over 3. So sin x by cos x is basically 10x, which is equals to 4 over 3. And I have just shown what they have asked us to do. In the next part of the question, we need to find the sum of the first 20 terms of the progression. So 10x is 4 by 3. So that means if I think of a right angle triangle, so if I consider this to be angle x, so opposite by adjacent, this is 4, this is 3, that means the hypotenuse must be 5, and this is a 3, 4, 5 right angle triangle. So even if you don't know that this is a 3, 4, 5 right angle triangle, you can find the hypotenuse with the help of Pythagoras. So that gives us square root of 4 square plus 3 square, which is eventually 5. So a is 2 sin x and a will be equal to 1.6 because sin x is opposite by hypotenuse. So 4 by 5, which is 0.8. So 2 times 0.8 is 1.6 and d is 3 cos x minus 2 sin x. So cos x will be adjacent by hypotenuse, which is 3 by 5, that means 0.6. So 3 times 0.6 and 2 times 0.8, that gives us positive 0.2. So sum of the first 20 terms will be n by 2 times 2a plus n minus 1 times d. So n is 20, so 20 over 2, 2a, a is 1.6, plus the common difference is, for this, the common difference was found with the help of 3 cos x minus 2 sin x, so that is 0.2. So sum of 20 terms is 70. Question number 10 is not in the syllabus at the moment because it has got to do with vectors. Question number 11. The function f is defined by fx is 4 sin x minus 1, where x lies between negative pi by 2 and positive pi by 2. We need to state the range of f. So this is the function. So let's first think of the grid for sine. The grid is 0, 1, 0, minus 1. Now if I multiply 4, that's what I need to do first. So 4 times 0 is 0, 4 times 1 is 4, 4 times 0 is 0, and 4 times negative 1 is negative 4. And if I then do minus 1 with all of them, I get minus 1, 0 minus 1 is minus 1, 4 minus 1 is 3, 0 minus 1 is minus 1, and minus 4 minus 1 is minus 5. So the range will be the maximum and minimum, which is 3 and negative 5. So the range fx lies between positive 3 and negative 5. In the next part of the question, we need to find the coordinates of the points at which the curve y equals to fx intersects the coordinate x's. So let y is equals to 4 sine x minus 1. To find the coordinates where the curve intersects the coordinate x's, that means at one point y will be 0 and in another point x will be 0. Or I can say at x-axis y is 0 and at y-axis x is 0. So 4 sine x minus 1 equals to 0. Simplifying this, I get sine x equals to 0.25. And therefore, the basic angle will be sine inverse of 0.25, which gives us the basic angle is 0.253. And we have to make sure that our calculator is in radians, because right now x lies between negative pi by 2 and positive pi by 2, and this is in radians. So now we know that sine is positive in the first and second quadrant. But since our limit is within negative pi by 2 and positive pi by 2, we can only take the first quadrant. So the basic angle is the actual angle, which is 0.253. And when x is 0, y is equals to 4 sine 0 minus 1. So sine 0 is 0. So 4 times 0 is 0. So we are left with minus 1. So the other coordinate will be 0 and minus 1. In the third part, they are asking us to sketch the graph y equals to fx. And as you can see, I have taken the limits positive pi by 2 and negative pi by 2. And the maximum is at 3. And the minimum is happening at minus 5. And the intersection happens at 1. This will be, okay, this needs to be corrected. So this will be negative 1 since it's below 0. And you also need to indicate the x coordinate, which was 0.253. So it's better that you definitely mention that this is 0.253 and this will be negative 1, not positive 1. And in the next part of the question, we need to obtain an expression for f inverse stating both domain and range of f inverse. So let's consider y equals to fx. So y is equals to 4 sine x minus 1. So 4 sine x equals to y plus 1. Sine x equals to y plus 1 over 4. X is equals to sine inverse of y plus 1 over 4. Now, since y is equals to fx, that means f inverse of y is equals to x, or we can substitute this x over here. So f inverse of y is equals to sine inverse of y plus 1 by 4. Therefore, f inverse of x is equals to sine inverse of x plus 1 by 4. And also, since they have asked us to state both the domain and the range of f inverse, which I have not written over here, I'm just telling you what it should be. So the domain for the f inverse will be the range of fx. So the range we found previously was 3 and minus 5. This will become the domain of f inverse. And the range of f inverse will be the domain of fx. The domain was x lies between minus pi by 2 and pi by 2. So that will be all for now. I will see you in the next video.